Welcome to another video. Welcome back to our YouTube channel, your YouTube channel, The Beauty in Math and Physics. Today we have an exciting problem on polynomial, something very interesting. So let us write together with the solution. We are given the quartic polynomial here, 8x to the fourth minus 8x squared minus x plus 1 equal to 0. So as you can see, the cubic term is missing. So this is a depressed polynomial. Now, I wouldn't want to use try and error or use synthetic division because this polynomial is factorizable at every point. Therefore, means that I have to employ factorization by grouping. So, solution. We have 8x to the fourth minus 8x squared minus x plus 1 equal to 0. So before we continue with the solution, if you are new on this channel, please do well to subscribe and turn on the post notification so that you can be notified anytime we upload a new video. And for all our returning subscribers, I want to appreciate all of you for your support and your love thus far. Thanks, and I appreciate. So let's ride with this problem. I'll group this pair, something very, common in the world of algebra, factorization by group. So as you can see carefully, 8x to the fourth and 8x squared, the highest common factor is 8x squared. That means that 8x squared can divide itself, it can also divide 8x to the fourth. So I'll factor out 8x squared, open a parenthesis, 8x squared divide 8x to the fourth, that will give us s squared. 8x squared divides is f, that's going to give us 1. For the second group, I'll just factor out -1, write s minus 1. So -1 multiplied by s will give -x, -1 multiplied by -1 will give +1. But if you look at the first parenthesis here, s squared minus 1 can be written as s all squared minus 1 all squared. This is actually a difference of two squares. So this can be written as s plus 1 in one parenthesis, s minus 1 in another parenthesis. So s minus 1 can come first. It's not, compulsory that you must write one particular pair first before the next. So in place of s squared minus 1, I shall infuse or substitute with these two factors. Then we are going to have 8s squared into s plus 1, s minus 1, minus 1 into s minus 1, everything equal to 0. As you can see, with this method, we've already obtained one of the factors, which is s minus 1. But if you look at these three guys here, they are a term in the world of algebra. Then -1 and s minus 1 are also a term. But you can see that they have something in common, which is s minus 1. So it therefore means that these two factors, that is the coefficient of s minus 1, I can multiply them together or distribute them. So if I use 8s squared to multiply x, that will give me 8s cubed. If I use 8s squared to multiply 1, that will also give me 8s squared. Then I will write s minus 1 in parentheses. I will write -1, then s minus 1 in another parenthesis equal to 0. So as you can see, because these two parentheses or bracket are the same, I can pick the outside factors. This is what we learned from basic algebra. So we are going to be having 8s cubed plus 8s squared minus 1 in one parenthesis, then s minus 1 in another parenthesis, everything equal to 0. So we've actually factorized by grouping. But we are not done. This cubic expression is also factorable. We can actually factor it as well. So I will repeat that. So we have 8s cubed plus 8s squared minus 1. I wouldn't put a bracket because I want to work on it. s minus 1 equal to 0. So to factorize this cubic expression, 8s cubed plus 8s squared minus 1, I need to split 8s squared. So if I split 8s squared, that's going to give me 4s squared and 4s squared. So I'll write 8s cubed plus 4s squared plus 4s squared minus 1 into s minus 1, everything equal to 0. So you can see the beauty of this problem. Then I will also factorize by grouping again. In factoring by grouping again, I shall investigate 4s squared minus 1. So 4s squared minus 1 can be written as 2s all squared minus 1 all squared. So this can be 2s plus 1 because the difference of two squares, 2s minus 1. So in place of 4s squared minus 1, I am going to replace it with 2s plus 1 and 2s minus 1. I would like to write 2s minus 1 first. So I will rewrite that entire expression, 8s cubed plus 4s squared plus 2s minus 1, 2s plus 1, s minus 1 equal to 0. So as you can see very carefully, we are doing well. So we have to factor by grouping for the very first pair. I'll put parentheses here as well. Then here, 4s squared is the highest common factor. I'll bring it out. Open the parentheses. I will use 4s squared to divide 8s cubed. That will give me 2x. I will use 4s squared to divide 4s squared. That will give me 1. So I will write everything. So as you can see again, for these two guys and these two guys, 2s plus 1 is also common. So I can take out the outside factors and add them together. So we are going to be having 4s squared plus 2s minus 1 in one parenthesis, 2s plus 1 in another parenthesis, s minus 1 in another parenthesis, everything equal to 0. So this is the very punchline of this problem. We are home and dry. So from the zero product property, it implies that 4s squared plus 2s minus 1 equal to 0, 2s plus 1 equal to 0, s minus 1 equal to 0. The only thing we shall focus on is the quadratic equation here. So I will take off this side of the board. So as you can see, like I said, for s minus 1 equals to 0, for s minus 1 equal to 0, this implies that if I take negative 1 to the right, it becomes positive, s is equal to 1. Also, for 2s plus 1 equal to 0, so this implies that if I take 1 to the right, it becomes negative, 2s equal to negative 1. If I divide both sides by 2, s equal to negative half. So our first root is 1, our second root is negative half. Then for 4s squared plus 2s minus 1 equal to 0, I cannot factorize this because this equation is not factorizable. So I shall use the quadratic equation formula. Formula says that x equal to negative b plus or minus b squared minus 4ac everything upon 2a. The ABC in this formula are from the standard quadratic equation as squared plus bs plus c equal to 0. So as you can see, our a is 4, our b is 2 and our c is -1. So I shall write that out. So a is equal to 4, b is equal to 2, c is equal to -1. So therefore, s becomes -2 plus or minus 2 squared minus 4 multiply 4 multiply -1. So this is 4ac. Everything divided by 2 multiply 4. So if you look at this square root here, -4 multiply 4 multiply -1, that becomes +16. So we can write that s equal to -2 plus or minus the square root of 4 plus 16, everything all over 8. I think I will rewrite this for our camera to capture it clearly. So I'll take off this part of the board. We are in the final lap. Like I said, there we have s equal to -2 plus or minus the square root of 4 plus 16 all over 8. So we are going to have, now 4 plus 16 is 20. So s will be -2 plus or minus the square root of 20 upon 8. So the plus or minus here tells us we have two solutions. So I'll call the first one s1 equal to -2. Okay, before that, this is an Olympics problem. So we shall use sword to express the square root of 20. So I can write this to become s equal to -2 plus or minus the square root of 4 multiply the square root of 5. 4 times 5 is 20. Everything divided by 8. I think it's simpler like this. Now square root of 4 is 2, square root of 5 is square root of 5. That's an irrational number or a radical. So I'll write s equal to -2 plus or minus 2 root 5 upon 8. The first answer will be s1 equal to -2 plus 2 root 5 upon 8. The second one will be s2 equal to -2 root 5 upon 8. So at the end of the day, if we try to simplify this, you can see that 2 is common on the numerator and denominator. So we can divide every expression or every term by 2. So that will give us the other two answers. So we are going to have, if I divide everything there by 2, s1 will become -1 plus root 5 upon 4. S2 will become -1 root 5 upon 4. So I can rewrite this to become S1 equal to root 5 minus 1 over 4. Then S2 equals -root 5 minus 1 all over 4. So hence the solutions to the polynomial are s equal to 1, which is the first answer, s equal to -half, then s equal to root 5 minus 1 upon 4, then s equal to -root 5 minus 1 upon 4. So these are the 4 roots of this quartic polynomial. So we've come to yet another interesting tutorial. Please give this video a thumbs up, share with your learning friends and colleagues. See you next in our next video. Bye.